Hello. Hello and welcome back to technical writing. You think? Did I get the right class? Yeah, technical writing. We're getting into some of the technical parts, right? Talking about how to document our code, which hopefully you've been doing to some extent for your whole computer science career. But now I'm going to teach you some of those hidden little secrets that we weren't supposed to tell you way down in the beginning. And of course, if we had taught you how to document your code properly in the first place, you would have been overwhelmed, and many of you would have probably quit computer science because documentation is the least favorite part of so many people working the computer science job. But unfortunately, for those of you who don't like documenting your code, it's one of the things that is most highly considered for your performance reviews and those sorts of things, at least at many organizations. So it's actually one of the most important parts of your job. Some would say even more important than actually writing the code. Some would argue documenting it is more important. It will definitely affect your career if you are not good at code documentation. So keep that in mind. Someone said bonus points made me like it. Wow, great. Look at that. Very simple psychology at work. I was able to dupe you into bettering yourself by offering you bonus trinkets of very little value. Haha. Fooled, made you a better professional in your face. I've got some new lighting today, so let me know if I'm too bright. I had some comments before that it was too dark, so I've turned it up to 11. I can barely see my screen because of all the lights pointed in my eyes. I feel like I'm on television, but you can let me know if it's good for you. I'll live with it. It's okay. I'll just squint at everything. All right, so code documentation, there'll be a homework on this that'll be posted right after we're done with the lecture here, so you're welcome to go work on it together a bit in Discord if you have some time at the end there. And of course the methods homework, the comparing different libraries homework is due today. A lot of people had trouble finding comparable methods. I'm trying to emphasize that they don't need to be perfectly comparable as long as they take similar inputs, they produce some kind of similar output. It's okay. You're not going to find four exactly named, exactly same functional methods, even in such a simple library as color in any language. And part of that is because they don't want to get into the kind of situation that Oracle and Google are in now, where they're suing each other over functions of their API. Part of it is just because they as part of the legal defense for the fact that you didn't copy an API. Part of what they usually claim is that the API has to be made from scratch. So the color library, essentially, they have to make it without peeking into anybody else's for reference. And so you'll tend to see at least the impression that they didn't copy their homework from a different programming language. So you'll actually very rarely see methods with the same name. So slight variations just in order to make it clear that they didn't cheat in their creation and that sort of thing. So as long as you find similar libraries, you are good. And don't forget to read all of the directions. There are quite a few. Remember, it was 4 languages, 4 methods in those 4 languages. And then you pick your best, you pick your worst, and then you pick one in between and try to do a better job. But obviously the text version of those instructions is much longer, so read carefully. Anyway, on to code documentation. By the way, if you have any questions on that assignment or something else, feel free to put it in chat. I'll just come back to it. So code documentation continued. All right, today we're going to talk about inline comments. You know, // that guy in Java. Some other languages, he comes out to be a £sign instead. Right? In some languages, he's an asterisk. In some languages, he's a hyphen. But he's always the inline comment guy. There's usually the inline thing, and then there's something else for the actual Java doc equivalent in that other language. So, for example, C# has // and that'll automatically generate a summary. Okay, so that's C#. I don't know off the top of my head any other languages Java doc equivalent, actually. I think 3 hyphens is one language. I don't remember which one. Anyway, plenty of different symbols, but we're talking about inline comments today. We're talking about the comments you write in your code. Just a couple lines, one-off lines. This includes maybe longer comments in the body of your code. And probably from the beginning of your computer science career, at least I hope from the beginning of your computer science career, you have been taught to write these inline comments on your code. You've been taught to clarify all of your code as you go. And these are great for learning, so I hope that you were taught this way because I think it really improves your ability to learn as you go when you have to explain what you just did after you did it or what you intend to do. It's very helpful. But once you know what you're doing, inline comments are not particularly helpful, and so you actually won't see them all that often in industry or in real productions. And that's a good thing. It's great for when people are grading you, but they're not particularly useful outside of that situation. We'll talk about some cases where they are useful down the road. There are certainly cases where inline comments are necessary and helpful and all of that good stuff. But generally speaking, adding a lot of inline comments is more of a burden than it is a help. First, you need to update them to stay accurate. So anytime you change the code, you need to change it in at least 2 places. As programmers, we know that changing your code in 2 places often doesn't go as well as you'd think. Generally, somebody will forget to change it in one of those places. That will cause problems. It's one of the main reasons that we have code reuse, like methods and those kinds of concepts, because we know that changing code in 2 places is a difficult thing indeed, and changing a comment in the code just as difficult. So comments tend to float to inaccuracy very quickly. And if your code needs comments, if you felt the need to add inline comments, then others probably need to read them to know what's going on, and that's extra reading. Okay, there's generally a way to accomplish what you want to do with an inline comment, or what you've done probably historically through your learning career. There's generally a way to accomplish what you would have done with an inline comment by just making everything clearer in the first place. You want to give the reader as little reading to do as possible. And remember, again, the reader is probably going to be future you. It's very unlikely you'll remember everything that your code does, even let's say in a month. And you want to be able to understand it a month from now. That means you've got a choice, inline comments or something else. Alright, so instead of inline comments, what do? Well, we try to write clean code. There's a book about that somewhere. I'm referring, of course, to the course textbook, Clean Code, which, by the way, has the same perspective about inline comments, that they are essentially useless because they require you to change them in 2 places, they drift to inaccuracy, all of those different things. That's not necessarily a majority opinion, but it's definitely a common opinion. And that's probably true of all the stuff I'm covering. By the way, on documentation, you might end up in your first job and everything is completely different because of some organizational culture. And you might end up at a 70s or 80s style firm where documentation is written kind of closer to legal documentation, where it's just long documents explaining everything. You never know where you're going to end up. So I hope that this is a more common approach. It's definitely not the only one. So sorry if it all ends up being useless to you, but I'm confident that it won't be. And for your own projects, I feel strongly you should do it this way. But you never know what your company is going to do. They might do something very stupid. They might require you to write all your documentation in Dutch. You don't know. So you should try to make your code clean, and clean code, some people describe it as self-documenting. This is kind of a phrase that comes out as a joke in the industry. Whenever you have bad code and there's no documentation, you always just joke, oh, it's self-documenting. So self-documenting is a punchline. Bad code is quote-unquote self-documenting because it's, impossible to read, and that's the joke. But there is a real thing in terms of being self-documenting. Self-documenting is a goal to strive for. Comments are a crutch, essentially. You want to avoid having to write them. You want to not lean on comments to explain your crappy code. You just want to write code that's easier to understand. So let's talk about a few ways you make your code self-documenting, for real, not for joke. First, your variable names are probably the most important thing. Your variable names should be excellent. The only thing that's maybe more important than your variable names is your formatting, but formatting is kind of a given, and if the user doesn't like your formatting, they can always use their IDE's auto-formatter and get her pretty close to a decent format automatically. So variable names, I think, are the most important thing. Your variable names should be excellent. I don't mean that they should be roughly good. I mean that you should do a lot of consideration when you make a variable. You should really name it nicely. And this doesn't necessarily apply to homework. I certainly don't do it when I generate examples for you guys. But when I write my own projects, I spend a lot of time thinking about my variable names. And if I decide that a variable name doesn't suit the need that it's assigned for, I go back and I refactor it out. I'll change its name. I try to make sure that all the variable names stay as accurate as possible and descriptive. That means that sometimes they end up being kind of long, maybe longer than we'd like. I think recently I've started to favor snake case a little more for this reason, because snake case, which is using underscores, let me toggle up into Eclipse for a minute and give you guys an example. We'll go over the rest of this later, but let's say I wanted to make an integer in snake case. So let's say math exam scores. In snake case, you separate everything with underscores instead. This is the standard in languages like Rust, and it's acceptable in Java too. It's great for long variable names. Of course, the camel case equivalent is, usually lowercase, math exam scores like that. Also acceptable, but you want to do variables like this, variables that are really specific. You want to avoid something just like score. All right, so be descriptive. Have a standard that you use. You know, if one variable starts with, like I had in the example here, if one variable starts with math, and then you want to do the English exam scores too, don't be like exam scores English for the next one. You know, it's going to be English exam score. It's going to be the same format. So you need to adopt your own standard, even though there is no, obviously, public standard. There might be at your corporation. There might be some standard, but you've got to adopt some kind of standard for your naming. Definitely make sure that you keep your case consistent. Use camel or use snake. Don't use magic numbers. This is something that's really tempting to do, especially on homework. We all usually let it go, everyone in the department, because it's, you know, kind of required, especially earlier on. And then we start to write you on it a little bit more, maybe in 228 and in 328. But for the most part, no one's going to really knock you for using a magic number. If you're writing your own code, or if you're writing something for industry, just don't do it. Make everything a constant. Just put a constant at the top for anything you plan to use a magic number for. Once the code base becomes a certain size, magic numbers become incomprehensible. So basically, except for some of the maybe universal constants, like let's say you're splitting something into tens, and that's what the code does. You don't need to make a constant in 10. If you're splitting it into tens in that case, then okay, fine. You just use 10. Or if you're checking something against 0, you don't need to make a constant for 0. You can just use 0. But if it's something like the length of an array, if it's, I don't know how many times a day you're supposed to refresh it, anything that you end up using a number for, make a variable for it, make a constant. Anything that's a setting, anything that can be altered down the road, anything that should be easily changeable, you should be making that into a constant, and all of your constants should be placed somewhere on the top of all the classes that they belong to. Or in some cases, people prefer to group all of the constants into their own class, so like a settings class or a constant class. Both of those are fine. Some people don't like the constants class idea. They refer to that kind of derogatory as a god class, because all the other classes reference it, and you always need a reference to it. And that's a valid criticism, but it is nice to be able to change all of the settings in one place. So I think there's something to be said for that. Now, obviously, there are a lot of exceptions to these rules. Of course, you don't need to pick descriptive and thought-out names for temp variables. It's perfectly fine to call them int temp or string s or whatever if they're only going to be used on a couple lines and then destroyed. And that goes for one-offs like the I in your for loop as well. If it's for int I equals 0, whatever, you don't need to call that int iterator through by and the name of your array or something. That's totally unnecessary. I is completely fine in that situation. So for your one-offs, you don't need to give them complicated names either, and same for your temps. But sometimes you make something, you think it's a temp variable, so you just start with string s, and then it ends up being a convoluted process that it goes through. And then sometimes it's a good idea, again, to go back and refactor it and give it a standard name and just go with s. And then with the one-letter things. It's very hard to keep track of them sometimes. So just bear that in mind. But don't end up in a situation where you have I1, I2, I3. That's probably the worst of the situations to be in. You want to avoid acronyms or abbreviations because I guarantee you will forget what they stood for in a month, and everybody else reading it will not know what they stand for. And that goes for even super obvious abbreviations, like instead of transaction ID, doing like tran ID, or instead of sum of grades, doing like sum G. Those are going to get forgotten too. Don't ever assume that your abbreviation is going to be obvious, unless it's a ridiculously long English word, or you really feel like you're going to be typing it so much that the savings are worth it. Probably don't abbreviate. And if you do abbreviate, I would even just go back when you're done and refactor it to the non-abbreviated version. It's always easy to change it back. Now, if it's a common word like ID or ATM or NBA or something, then yeah, of course use it. You're going to remember what an ATM is in a month. That's the main thing we're concerned with here, is are you going to remember what it stood for. So again, like transaction ID instead of ID, or tran ID, sum of grades instead of sum, or sum G. For replacing those constants, instead of saying it's 60 FPS, make a constant called frame rate, and put the FPS in that. Say frame rate equals 60. I always use all caps snake case for my constants, but you can use a different system if you prefer. I think that while camel case and snake case are kind of competitive for variable naming, pretty much everybody uses all uppercase snake case for their constants. I very rarely see other approaches, so I'd say that's probably the way to go. If you do have one-off variables, like in your for loops, be consistent. So if you're making a nested for loop in one spot and you called them IJK, call them IJK every time you make nested for loops. Don't switch to XYZ when you're making a different set of nested for loops. Have a system. It's like first I use I, then J, then K, and then if I run out of those, I go to whatever's next in my list. Maybe you go to XYZ after that if you've got a 6-deep nested loop. Okay, but it's the outermost loop is always I, the next inner one is J, the next one is K. If you do that, then you instantly know what portion of the loop you're in. Okay, if I'm seeing K's, then I know I'm talking about the third inner generation of the loop. If I see J, I'm talking about the second inner generation of the loop. So be consistent in how you use those as well. All right, second part about this is using the smallest possible functions that do the job, okay? So we've probably taught you to use functions for a variety of reasons. Hopefully you've learned about like solid principles, code abstraction, code reuse, just all of the different things that we use functions for. All valid points, but the main reason that we have functions and not a single one class, one function wonder for every program ever written, which of course every program could be if you tried hard enough. The main reason we don't do that is for readability, right? It's for the human meat bag that has to read it, because at the end of the day, when you go to compile it, it's all going to be just one big binary gloop, right? All of the different abstractions that you've created and all that fun stuff, it's meaningless when it comes down to it. It certainly has its advantages. I'm not saying it doesn't. It certainly can have advantages in terms of compilation and all that stuff too, but the main reason that we split code into functions is so that we can read them better. It's so that the code is easier to parse. So a good rule for me is once my function has made it to about half the length of my screen, and obviously this is pretty arbitrary because it's based on my font size and the screen I'm using at the time and all that business, but that's my rule of thumb. When I get to about half the length of my screen, I start considering how to split it up, how to refactor it into multiple functions, because at that point, once it's past a whole screen length, then you're definitely too long, because then you have to scroll. And once you have to scroll, that means you have to see the beginning and the end of the method. You've got to look at different parts of the screen. That's no bueno. So you pretty much want to have it at least so every method fits into your screen size somehow. But now this is not always possible, right? And what's worse than a really long method is having a goose hunt for functions. So you ended up having a really long method. You decided to split it into 5 functions, and you just split it into part 1, part 2, part 3, part 4, part 5 arbitrarily, right, without any consideration to functionality, you just split it into part 1, part 2, part 3, part 4, part 5, and now I have to look for those subparts. And maybe it's like a complicated math formula, and you just split it into 5 parts completely arbitrarily. So just part 2 just takes input from 1 and picks up where it left off, and that's no fun. So don't do that. That's even worse than having a long method. You're trying to balance length with locality and modularity. And what I mean by locality in this situation is that all of the method's information, all the content of it is in one place where you can easily read it. Obviously, if you split your method into multiple methods, if you split your function up, then it's not going to have that locality anymore. You're going to have to look around to find the entire function of it. But as long as the individual modules can be understood, well, you can still sort of achieve locality. At least they're all clustered together. And if you have a question about how an individual piece of it works, yeah, you can always go look at it. And then, of course, we're always trying to be modular when we separate our methods out. We want methods to be able to stand on their own. We want to be able to reuse them. So as much as possible, when you split up long functions, try to split up the most modular and useful parts of them. It's not necessarily terrible to have a method that spans more than a page. It can happen, but you should always be on the lookout for ways that you can mitigate that. The less you do that, the better it is to read your code. So, shrinking functions. Let's say, and I'm gonna ask a question for you guys. I think at least some of you have taken design patterns. So why don't in chat just describe to me either what is a singleton or what is a factory. So just answer. We're gonna have it near here in the slide. So what is a singleton or what is a factory for those that have taken design patterns? So if you have a method, let's say, and the first thing you do, this method processes some object or creates an object or uses an object. The first thing it does is set that object up, then it does something with it. We can call that B. So setting it up as A, doing something with it as B, and then we're done with the object and we clean it up C. So let's say, for example, you have scanner. All right, you're taking input from the keyboard. What's the first thing you do? You say scanner scan equals new scanner system.in, right? So you've set up your scanner. That's good. You don't need to do anything else for scanner, but some objects have a lot more setup, right? Let's look at JPanel, for example. Frame equals new frame. Then you name it. Then panel equals new panel. Then you name it. Then frame dot add the panel. Then pack. Then something else. Then set visible. That's a lot of setup, okay? Now let's say after that, you had a bunch of stuff you needed to do with the frame. Maybe frame.set title, frame.move around, frame.who's or whatever. All kinds of stuff after that. That's B. And then on C, when the program's done, maybe you've got some kind of infinite loop up there, and then when it ends, you got your cleanup. C, frame.destroy, frame.dispose, frame.whatever. All of that different stuff. I still don't have any answers in chat, by the way. I got one in the Discord for what is a singleton. Someone said a singleton is an object that is restricted to having one instance of it. Yeah, it's a pretty good definition for a singleton. So let's see if we can get one for a factory. So what does it mean to have a singleton? So kind of like I was talking about that constants class, for example. One of the ways that you can accomplish that is to have a singleton of your constants class. And everybody references constants.getInstance. So usually when you have a singleton, you've got some kind of static or globally accessible getInstance method that lets everybody talk to that instance. And this avoids you having to do some static voodoo, avoids you having to have a static class, essentially. But it also avoids you having to do a bunch of setup when you instantiate. Let's say your static class, where you have a bunch of different functions, has a bunch of setup that it needs to do before any of those functions can work. In that case, you make a singleton. When the singleton is created, it handles all of its own setup, and none of that is going to have to be inside of the method that we're talking about here. All of that stuff that's supposed to happen in A happens in the singleton setup, and our method can focus as much as possible on B. So what we want to do as much as possible is make sure that our use cases, the B part of any method, stands alone as much as it can. That we basically restrict that A and C portion to hopefully one line or similar lengths, and most of the body of the method is comprised of actually using the object, the B portion. There's no equivalent to a factory for object destruction. I don't think there's at least a terminology for it. I know some people call it like a recycler, something like that, instead of a factory. But you should have some sort of cleanup model for your objects too. So we talked about frame. Frame has dispose. Scanner has close. Those are both cleanups too, to finalize whatever that object needs to do. A lot of the time you'll have a model where objects all need to register with some sort of master, maintain some kind of, let's say, master class that controls all of your frames. So it has an array of frames or something, and every frame that gets created gets registered to there. I still haven't got an answer on what a factory is, by the way. So every frame that gets created is registered there, and if you want to, let's say, access all of the frames that are created, you can talk to that class, and it'll return for you a list of all the frames that are created. Well, of course, when a frame is destroyed, you need to tell that class that it's been destroyed. And so that kind of cleanup should happen as well in its own place. Maybe that master class has its own cleanup method, and you provided an argument to the frame, so you just provided this and it finds it. Maybe you have a frame.dispose method that informs that master class when it's going to be removed, and tells it to remove itself from the array as it deconstructs itself too. All kinds of different approaches to do it. Just make sure that, generally speaking, you don't have that A, B, and C code in the same method. You split those up. That's just one example of shrinking functions to make them smaller. You always want to split up functionality so that the use case can stand alone. So you always want methods where their inputs and their outputs and everything they do can stand alone as much as possible. They don't depend on a bunch of other entangled code elsewhere. All right, since nobody answered what a factory is basically a way to create objects. So let's say that you have like a frame has all this complicated setup and stuff. So you would have a frame factory, and you would say frame equals and frame factory dot make me a frame, and make me a frame will make you a new frame, do all of the initialization and setup that the frame needs to work, and then return it to you. Okay, so whenever you need a new frame, you don't say frame equals new frame. You say frame equals frame factory dot make me a frame. And typically the factory is a singleton or something. There's only one factory for the program, and the advantage here is that all of that frame creation code and all of that instantiation stuff happens in one place, and it's all standardized, and everything is much easier to read in that case. And in instances like with frame, or you might need to pass it like a custom title or a width and a height or that sort of thing, the factory would take all of those arguments and then make an object with them as needed. So it's a very useful design pattern. If you haven't already learned about factories, I think singletons and factories are probably two of the most useful ones. So you should definitely look into those. And if you haven't taken design patterns, I think it's being offered next semester too. So think about it. All right. Don't be clever. Don't be too clever. Don't be clever when you don't have to be clever. It's good to be smart. It's good to know all the cool new programming tools. I've certainly run into so many little snippets of code, even from new students all the time. I run into so many things in Java. I was like, wow, I did not know you could do that, but I would never ever do that. So it runs into a situation like that. The first rule is don't optimize. There's a saying about optimization, right? There's two rules of optimization. Rule 1 is don't do it, and rule 2, which is for experts only, is don't do it yet. So you might be thinking, well, the way that I did this, it's readable, right? But it's so inefficient. Well, if there's no problem with it and your application isn't running slowly, and it's not something that's going to happen a million times, just live with it for now. If it becomes a problem, you can fix it later. Prioritize the readable over the perfect. There are so many tricks to getting your code to be more optimized. For example, when you use strings, right, when you concatenate them together, that's actually a really slow operation. The compiler sucks at it, Java sucks at it when it's running. Everything sucks for string concatenation. There are ways to do it that are faster. They're also way harder to read. So Why would you do that? Just do concat. It's so much easier to just say string plus other string. Are you ever going to run into a situation where that creates a slowdown that's too much and actually adversely impacts your program? Maybe. And when you do, you can go back and fix it. But for the most part, prioritize your readability over your perfect optimization. You don't want to write terribly optimized code, but you can make it decent, not perfect, but readable. That's a good territory to be in. Okay, and then back to those tricks like lambdas and ternary operators and all that stuff. Yeah, those are cool. Okay, and occasionally you'll run into a situation where you can actually make a good lambda. Like it's actually easy to read, it's easier to understand, it's easier to maintain because you've replaced like 8 lines with a lambda and you haven't lost anything because you mostly just lost like semicolons and parentheses and brackets. Fine, cool, do it. But don't always use them. You can lambda everything. There are so many programs where you could, if you really wanted to, turn them into a single super long lambda expression in like one line that just spans across half the page. The power of these tools is incredible. That doesn't mean that you need to use it all the time. There's no award for shortest piece of code. Sometimes there's an anti-award for shortest piece of code. The most optimized, the shortest possible code really is you want to go back to assembly or something. That's not necessarily going to be the easiest to read. Shortest is good. You do want to try to make it as short as possible, but there are limits to how many tricks you should implement to try to get the smallest possible line count imaginable. So stick to the basics. Just use conditionals, loops, assignments, and functions wherever you can. You don't get any extra credit points either at school or at work for your 6-function super lambda. Yeah, it looks cool, and again, sometimes it's useful, I guess, but for the most part, I mean, I would never touch them because I just don't see the point. Same with ternary operators. Like, it's cool, but it's less readable than a block of if statements, in my opinion. Some people would disagree, but okay. And switch statements are one that I would say are fine. Switch statements can be a lot cleaner than if statements in some situations. So definitely switch statements instead of long branching ifs. Usually once I have 3 or 4 branches to my if, I switch to a switch statement instead. I think that's a pretty fair rule for the most part. Or if you anticipate having more than 3 or so. Enums are another one I didn't mention here, but enums are very useful. So if you have a typing system, like type 1 equals whatever, type 2 equals whatever, better to use enums instead. Much cleaner naming system than having them be constants or something. So definitely use enums. If you don't know how to use enums, it's really quite simple. So just look that up real quick. I can never remember the syntax, but they're very easy to use once you've got them set up. If you're using loops, generally, and hopefully you learned this back in intro, right? If you have a discrete stopping point, you're going to use a for loop. If you have an open-ended loop, you'd probably use a while. So if you're looping over the length of an array or something, from 1 to the length, okay, use for. If you're looping until the condition is not met and you're not sure when that'll happen, okay, use while. And make sure you limit the amount of functionality in your assignment statements and your conditionals and stuff. If you need to, in order to create a new frame, so if you're like frame equals new or frame factory dot frame, I'm gonna like 6 arguments and then dot instantiate dot give me the frame dot please now. That's too much. Okay, split that up. You can split that up into multiple lines. If there's way too many. If there's way too much information in your assignments, then you probably are better off making a factory or some kind of method that generates your objects. So make sure everything on the right side of the equal is not too long, basically. All right, so a lot of companies are going to make you write tests anyways, right? So unit tests, integration tests, whatever. You're going to write a lot of tests, most likely. Pretty much anywhere you work, you're probably going to write tests. So if you're going to write tests anyways, then try to make your tests into comments too. In that sense, be very descriptive about what the tests are doing. Generally, in any language where you can write tests, you get to write some sort of string message that displays when the test runs or when the test fails, make sure that that message is very descriptive. What are you testing for? If you get to write some kind of debug output when it fails, say specifically what probably failed, or specifically what failed in that test. So if you're checking for is the score greater than 10 and the test failed, report the score is not greater than 10. That's as descriptive as you can be there. You probably won't be writing any tests here, but we might do some tests as well in this class too. And of course, formatting is very important. You got to have a lot of white space. Be generous. Don't compact everything together. You got to have consistent spacing, consistent semicolon placement, consistent bracket placement, consistent parentheses placement, consistent quote placement. Whatever you use, be consistent about it. Use a constant line length for languages where the lines don't matter. So sorry to Python users, I don't know what to do for you, but for those of us that can make new lines willy-nilly, for example Java, make sure that you have a max that a line can be, and don't go over that. So if the line is longer than that, well, it needs to be split into multiple lines. That makes everything a lot easier to read. Horizontal scrolling is one of the most time-consuming tasks when you're reviewing a lot of code, right? So make sure everything can be vertically scrolled. Long conditionals and long inputs, put them on separate lines. So if A and B and C and D and E and F and G and H, you can probably put either, let's say, A, B, C, D, E, H on their own line, E, F on their own line, or you can put A, B, C, D, E, and F on their own line. However you see fit, just make sure you don't have a very long conditional that, again, spans over the line length. And I like to separate, once I have more than 3 conditionals or more than 3 arguments to an input, like for an object creation or something, or a function, I like to put each input, conditional, or argument or whatever on its own line. So once I have like 3 or more, I put all of them on their own line, unless they're like a single integer or something. Makes it a lot easier to read when everything is on its own line, even if that's, kind of a waste of a line, right? Doesn't matter. Lots of white space, inputs on separate lines. It'll be easier to read later. Always match indentation. Your brackets need to match. Your nested for loops need to be properly nested. Make sure everything is nested correctly. Your IDE is usually really good at handling this and other bracket pairing problems, but it doesn't always do perfect. You have to do a lot by hand, especially splitting things into multiple lines. So the IDE is not human. It doesn't have to read. It doesn't recognize when something needs to carry over to multiple lines very well. That said, Eclipse and, let's say, Visual Studio both have really robust formatters. They can do almost all of this for you, and they're right, or good at least, like 99% of the time. So if you just set up your formatter, there's plenty of settings in Eclipse and in Visual Studio and wherever where you can change how your auto format works. Take some time to set it the way you like it. Okay, those settings are pretty easy to access. There's tons of them. Take some time to set it up the way you like it. All right, so when should you use inline comments? Well, if there's an extremely complex operation that you just can't simplify, and it's obviously going to be complicated no matter what, something like finding the 6th power of the 25th prime or something, I don't know. Or there's a server handshake procedure that's just an exchange of keys that's completely arbitrary and it's just really complex. Yeah, you gotta do some inlines on those. So if it's very complicated, leave an inline comment. This is why we teach you to leave inline comments when you run into something complicated as you're learning, right? Because you should continue to do that. You should just raise your bar for what complicated means as you get further in your career. So obviously you're not going to be documenting every system.out anymore. You shouldn't be, right? You should be up to the point where system.outs to your mind read the same way as this prints to the screen. You know that by now. So don't document that kind of thing. But things that are still difficult, and this is all subjective, so things that are difficult to you, feel free to leave an inline comment to clarify. So if you have some sort of existing type system, this is where enums shine again, because then you don't have to leave these kinds of reminders. You can just check the enum. You can type the enum's name dot and then see all the different possibilities. But even in that case, sometimes the possibilities have some sort of description to them. So if you need a reminder because you're using it somewhere in the body of the code, it's not a bad idea to leave an inline comment that's a reminder. This is assuming that you're not going to change that type system, which you probably won't. Obviously, to-do comments and bugs to be. I leave a lot of to-dos when I code. You should too. Just / to-do and then what you think you need to add in the future. Those kinds of notes to yourself are very useful for present tense programming. Obviously, you want to remove those as you go, but those are very useful to make your day-to-day more productive. Just put those to-dos in there, say what you need to do, and then you can easily search for all the to-dos in your program and knock them out one at a time. Likewise, for bugs that you just haven't quite fixed yet, but you've noticed, you can either leave a to-do or some kind of equivalent documenting that you found that bug. You'll go back and fix it later. Now, you will continue to learn your whole career because CS is very rapidly changing, and at a certain point, you will probably need to mentor people who are below you, right? At a certain point, you will be more senior. So at some point, you're going to need to create educational content too. At some point, when you realize that you have mentees who are not as skilled as you, and what you think is simple might be confusing to them, then perhaps you should start adding inline comments again. This goes the other way to an extent too. You can document to your superiors where you have confusion or what portions of the code that you don't understand. But once you get into the point where you're doing something complicated, sometimes it can be helpful to just leave comments for educational purposes. And this is true especially of projects you post publicly, like something you post to your GitHub profile or something. You never know who's going to look at it as a source. So especially if it's an open source project, leave educational comments about what certain things do inline. You don't want to put those in the headers or anything because those are only interested to people who are deep in the code. But inline, yeah, leave educational content if that's something that you want to do, and you should. Warnings to future readers can be very important. Sometimes there appears to be a very obvious fix to something or a very obvious simplification. And if somebody does that very obvious simplification, it breaks everything, right? So if there's one of those situations, make sure to read a warning. Don't touch this. Don't do this. Don't mess with this particular code. Don't set this 2 to a 3 or everything is ruined. Those kinds of comments can be very helpful. You want to make sure, especially if you've made a mistake and it turned out to be difficult to fix, leave an inline comment to at least briefly document your mistake so nobody else repeats it. And then vice versa, you can add do's. Make sure that people do what you're supposed to do in this particular line or whatever it is. Maybe you need to do something very specific with how you pass the variables along, or something very specific in how you process it. Well, you should leave those kinds of very code-centric decisions documented as well. Last thing we're going to do today is look at this famous, very famous, it's not that famous, but it is one of the more famous blocks of code. It's from Quake 3, which ran a very, very long time ago and was one of the first games in 3D, definitely one of the first, I think, multiplayer games in 3D. And this was a function that they used to convert, I think, inverse square roots. So here's an example of bad documentation in so many ways. Number one, function's name sucks. It's a bunch of abbreviations. Q underscore R square root. What the heck is that, right? Number two, they named the constant 3/2. 3/2. 1.5f is 3/2. Does that even need a name? Yeah, actually, I would say it does. So this is a good example of them not using a magic number. However, the inconsistency of using 3/2, which was a constant, but then later on using 1/2 as a magic number, right? You got 1/2 just as a magic number, but 3/2 gets to be a variable. Now that's just weird. Okay, either make them both constants or just treat them both as magic numbers, which is not preferable. What does this do? How does it work? Anyone have any ideas? How? Evil floating point bit level hacking is our description here. If you're not familiar with C, This is pretty much illegible. You've got a dereference long, a dereference, and then a reference. What? What is that? I don't know. Anyway, you're getting something out of Y. Looks like you're getting some bits based on this comment, and then this is what? What is this? A byte address, and then a minus, and then a bit shift to the right by 1. What? Yeah, that's exactly what they commented. What the fuck? Because who knows what that is? And then some more bit level hacking, going back to this I up here, and then some iterations here. What is this? What does this do? Anybody? Anyone have any ideas how this works? This is a good comment, though, by the way. They have first iteration and then a tip for future programmers that you can do another iteration. What they should have said as well here is that this improves precision. More iterations, more precision. So you could add this as a tip to future programmers that this can be removed, or something to the effect of that more iterations equals more precision, so that people know they can just add this back in if they would like it more precision. So what does this do? What does this do? No one has any guesses? Someone said maybe it's something for movement. Oh, this is a actually relatively simple trick for approximating square roots in binary. It happens to be that this exact number, I don't remember what it is, this exact number, if you do a bit shift, just because of the way binary is, you do a bit shift, you do a couple other things, and you can get the square root approximately. And hardware back in the day would require a lot more effort to get a real square root, or maybe this is an inverse square root. But either way, that operation to do it the real way, the not approximated way, would have taken something like 100 times longer. And so this little efficiency hack, this was an example of optimization after the not yet. So the original was too slow. They had to fix this in order to get the game to really perform at a reasonable level. So they came up with this cool mathematical technique for approximating the square roots or the inverse square roots or whatever using some fancy binary math. But then they did not do a great job documenting it. So don't be this guy, even though this guy obviously very, very smart to come up with and implement this thing. Obviously, something like this, which is short, a nicely contained function, you're looking at 9, 10 lines of code, right? Really clever, but also unreadable. Okay, so useful, but yet also useless, right? Because although it works perfectly, if you ever need to make a change, good luck, right? If you ever need to figure out why this particular number, good luck. So leave some freaking comments here, guys, if you're into something like this. All right, let's look at some Eclipse fun time, how to leave good Java.comments. A couple things you probably didn't know about Java.comments, because your homework, which it looks like you're going to get about 15 minutes to work on at the end here, is based on making a supercolor class that extends color and adding some functions to it. And I am going to grade pretty much solely your documentation. You need to come up with some reasonable implementation of the methods that I ask you. But it certainly doesn't have to be good. And I am going to grade your documentation. I actually don't hate strings, and this is the only message I could come up with. One thing, by the way, I'm going to add is always delete those to-do stubs. You can change it in the settings so it doesn't make those as well. But don't leave to-do stubs in your code. That's just bad. Just bad practice. All right, so first I had those snake case examples up there for you. Here I've got my hatred of strings as an int, and you'll notice that if I hover over it, I get the Java doc for it. On a scale from 1 to 4, my hatred of strings is 5. It goes off the scale. And then I have the constructor that I inherited from supercolor here, and notice it has no documentation at all. Okay, so this is inherited from color. I would like to get colors documentation here. So let's see, how do I do this? All right, here I've got method toString. Now we know color's got a toString method, right? So here we've got method toString, and I would like to get the original documentation for toString as well. So I've added some. It now says just returns null because strings are for losers, and then for the original C. And also, if you haven't used this before, remember Java docs accept HTML because they're designed to be viewed in your browser. So if you want to make a line break, you can use BR. You can use all kinds of other HTML tags too, like bold font and italics and all that fun stuff. I think you can even reference images if you feel like it. All right, and so if you want to inherit the documentation from the superclass, you're going to use this @inherit_doc. So it'll actually recommend this for you, I think, if you start typing after a bracket. There will be some options for you. You can do link, literal, summary, value, inherit doc. Let's do inherit doc, and then we also go with doc root, and let's see what that does too. All right, so if I hover over it, I see this is an @override. I see my original comment right here. This says just returns null now because strings are for losers, and then for original C, and then the original starts. So you can see the whole thing. Okay, and then I see at the end here this file C Eclipse workspace 475 source. So that's what you get for root. You get the root directory that it's in, which you might need for something or another. All right, so that's how you inherit documentation from a superclass. That can be very helpful. If you want to just link to documentation for another method, this can be really helpful too. So here I have returns the only string in this whole class for more on my hatred of strings, and then I want to reference this toStrings method description. Okay, and so I need the package name. In this case, the package is documentation sample, and then I need the class name. In this case, it's supercolor, and then to reference individual methods, you use the hashtag, and then the method name, you can also reference individual variables with the hashtag or the £, or whatever you want to call it, and then the name of the variable. All right, and if I hover over it, I actually see that documentation here, if it worked correctly, if it linked correctly. If I make one typo, then I'm just going to get nothing. It's going to be empty. So you have to make sure that you make no typos. But if I make no typos, then it shows me returns only the string in this whole class for more on my hatred of string C, and then it adds this C also section at the end. So this break wasn't actually necessary. I just copy and pasted it from there. So it adds the C also section at the end after the returns and stuff, and there you can make a bunch of links. So if you want to have this C also section at the end, you use this @C thing. And you can click them, and I'll show you the documentation for that toString method. Now, if you want it to be inline, so if you want the link to be inline instead of in that C also section at the end, then you're going to use link. All right, so here I have returns the only other string in this whole class for more on my hatred of string C, and then I have linked to the toString method. And notice here I've omitted the package name and the class name. Let's see if I can do that here as well. And voila, I can, right? So that's helpful. This allows you to actually link to documentation from other projects that you have open in Eclipse, so you could actually link to, I don't know, any of your other packages here. So this is the complete name, but if you're just linking to something locally, then you can just use the hashtag, or if you're linking to another class here, for example, if there was another class besides supercolor, I could link to it like that. All right, and what link does instead of putting it in the C also section is it puts it inline there. So now you see returns the only other string in this whole class. For more on my hatred of strings, see a description of my hate. You click there, you see a description of my hate. You can always use the back arrow, or you can use the back button on your mouse, I think. Nope, no back button support. Sorry, Eclipse. And you can click my level of hatred to see the on a scale from 1 to 4 comment. Notice the other thing I've done here is up here on my C, it just links this whole doodad here. You can also name them when you do @link. Kind of like if you've done HTML, you can do href, you do the link address, and then you name it. So here I've named it a description of my hate. If you don't name it, it'll just use the default name of the method there. So you can name it or not. And this allows you to make links inline. So you can do something like, this is a link in the middle of the line. And you would put it, let's say, somewhere right in the middle there, and that'll parse, and you'll have a link right in the middle of the line. This is a description of my hate in the middle of the line. You can click it. Very helpful. All those different things you've probably seen in Java's documentation, all the built-in documentation before. This is probably the first time you've used it, though. All of that's real helpful. So how do I get my constructor here to refer back to the original constructor in color? How do I get this to refer back to my this super constructor for float, float, float color? What do I do here? Let me try this. Try this guy out. How does that work? What do I do? How do I get the original color constructor with 3 floats? What do you guys think? Can I do a C? What do I do for a C? And what do you do when there are multiple different methods named, let's say, toString that take different arguments? Because there are many constructors for color, not just the 3 floats ones. Someone asked, when will the homework be due? 1 week from now. Next Tuesday. What do I do? I'll leave you to ponder on this as I upload the homework as well. So take some time, read the homework. I will be in Discord to answer your questions, and otherwise, you know, just would be just that color. Let's see. So you want to just try color, and then what? It doesn't have a constructor. Do I just do that? That's something, right? That's something. What if I tried this? What if I tried color, float, float, float? Does that get me anywhere? Nope. Color? Nope. Pound color? But there isn't one. How about pound color? Float, float, float. As you can tell, it's kind of a formatting nightmare. Something I always have to look up. Closer. Except it's linking to documentation sample .supercolor .color. So it's looking in the wrong place. What about this? What if I tried that? Ta-da! Okay, so it took a while. It took a while, right? It's not as easy as you would think. But hey, better than nothing. I think there's an easier way to do this too. I think there is like an inherit constructor or something. And there are a bunch of other different cool ones. I've asked you to use @author for the documenting your senior design stuff. So make sure you're familiar with @author. That always adds it to its own special place too. Just like the C alsos go to their own special place. And it'll fill in your machine's name there. So if you haven't named your machine, like obviously mine's called Dr. Fish, so if you haven't named your machine on your own name, you can feel free to just use your machine name for those @authors. You can also add notes like hidden and depreciated and all of that stuff like that. Tons of good things there. And always remember to document your parameters and your @returns as well. So you have your @return here. You should always document something like the exact string I hate strings. And that goes again to its own special place. Exact string I hate strings. You should document your parameters as well. Redness from 0 to 1. And that again goes to its own special place down here. All of that stuff very useful for your method documentation. Alright guys, that's going to be it for today. I'll see you in Discord if you would like, and see you in 30 minutes regardless. So, thanks for watching. Like, comment, and subscribe. Adios.